So I'm going to explain a little bit about the OLED display driver, how the file system is. If we look on the CMake list file inside main, then it is important to integrate all C files which should be compiled together. So therefore this one for the OLED control has to be mentioned here just in quotation. And you can also here have an include file if necessary, but the include file is just in the main folder here. So that has to be added to the inner CMake list file. And then the controller here is linked to the standard I2C driver belonging to the Espressif's RTOS system. And the initialization is moved from previous version to this version inside the C.C file here. and the content is the same, except I have taken the address for the OLED I2C, which is specified in the header file. Then these are as normal for an I2C, where we have to define the pins, the legs, and it can be any leg if you prefer, but here I have taken the standard for the data line, leg 16, and for the clock leg 17, and then I have pull up. The reason for pull up is that the data line here is bidirectional. The pull up on the clock is absolutely not necessary, but it is. And then we are setting the clock speed, and that is actually the maximum regarding the data sheet for the Espressif. And then there is a statement here which actually take the I2C 0 configuration as master, and then it adds by reference to all these. So by this statement you initiate the physical legs, and then we install the driver, calling a standard function for that, and in the console we write out it is succeeded, and then we create an handler and so forth, just to see that we can get in touch with it. That's the purpose of these here, just to see the address actually is correct, and then it returns OK. So it has a return type error, as ESP error type, and that can be printed if we like. I have not printed it. And the rest is the standard one you have had seen before. We simply use the I2C library belonging to the Espressif's RTOS. That's it, actually. And if we want to see it is running, then we of course compile, and then we flash it, and then we can open the monitor from here, and it will open up, and we can see it is executing here. As you can see, the driver is installed. That is printed from the function we saw here, and we have the address, and then it is running in a task, and the task is specified here in here. And I have made a little delay here, and then I initialize the display and reset the display, and then I'm running in a loop here where I'm incrementing a counter and converting it to an ASCII array, and then I send the ASCII array out on line 6, and then we can see the counter is incrementing here approximately with a speed of 1 second. So that is the task performed in created by this statement down here, and then I call initialize display here. I call the initialization function in the file here, and then it is simply executing. So that's it. But next step is, of course, to shut down here, Control C when we get out of this. What I want to show is how to invoke and sensor together with that one, a digital I2C sensor. So we have a sensor using the same hardware, and that can make a little bit trouble for you perhaps. So I will close this folder, and I will open up the other folder where it is, I hope, open folder, and I have it in my platform IO here. Platform IO, and it is here. So I have taken the pressure and temperature sensor and integrated it together with an OLED display. So I get the pressure and temperature written on the OLED display. So the source code is, it should be in main. No, yeah, sorry, I have to select first. Sorry. We select, and when we select, it is actually trying to do the configuration again. So if you move from one laptop to another one, then and you move the whole project and unzip it and open it up, then you get disturbance in your settings if it is not exactly the same. So the only thing you need to do is to take the source code and create a new project on the other laptop and compile it from scratch again. Else there will come a mess in the settings, and the compiler can eventually not be found. So many things will go wrong. So take the files, move it, copy paste it into a project created on a template, override the main, and then it should run. So recap, here we have the SSD 1306 driver, and then I have included my ASP.EDF-lib master, where the many digital sensors have a driver specified, so it's more or less ready to use. And outside in the other, we have to put a link here, as you can see here. I have written or uploaded an example, and if you use the backslash, then you have to escape them by an extra backslash, then it is okay. Else you have to move them to slashes instead. But we have to point directly down to the directory with all the components. And if you look in the file here, then let's see, where is it? I have to click here. ESP, here it is, and then all the components, drivers are specified here. So all these devices here is implemented. But there is one point here. The I2C use its own driver specified in this here. So there will be a little conflict, but it is overcome here in this setup. Alternative would be to port this driver here to use this one. I have not had time for that. That could be a nice exercise for you to do, but I have not had time to it. And for all these nice examples, there is examples here. And what I have taken is, I have been in here, in this one, and there is an main file. I've simply opened it up and copy-pasted it into a common main here. So if you open up the main, then let's start from the main function. I have to use mutex here to be sure not to overload the I2C bus as well as data. So therefore I create a mutex, and the print mutex is the variable carrying the mutex, and it is made up here in the top as a semaphore handle. So the mutex is a semaphore. And it is necessary as we have two tasks running in parallel, sharing the same data and data bus. Now, then next I have here just to find faults, included this one. It does not mean anything, and then I can print it out. The reason for it there was of course some problems. Now, instead of using initialize display here, then I call the I2C develop init function belonging to the extra library here, and that means I prepare here the I2C so it can be working together with the BMP 180. And I have a little delay here, and then I create the two tasks running in parallel, the OLED display task and a new task, and it is a little bit different. It is pinned to core, and the reason for that is we can add the CPU core here. You can see define CPU number 1, so it is running on that core. It could also be running on the standard way down here. Now, so we have the two pointers here for the two functions implementing the tasks. And the first one is our display. And now I can't use my initialization we saw before for the display. So I just initialize display, reset display, and then I go into my while where I take the semaphore if it is a variable, else it will jump over, and then I release it down here, and else it is more or less the same, except I have not the counter. And the other one is taking the BMP, and it is creating here the interface for it. It is making the invoking of the I2C using this special driver for I2C belonging to all the sensors, having the same pins here as the other one. And then I have a while here where we are measuring the temperature. So this function here is actually doing everything. And then I want to print it out on my OLED display. Therefore I have the need for using sprintf to convert these two integers to an ASCII array, and then I use the ASCII array in the other task to print out the you can see it here. So here I send it out. So no init function call as we saw before in here, no init call here, just an init call to the I2C bus from the main, the app main, and then we are going to use it. And if we try to download that then we can see how it works in the console. Then we have it here, and then I open up here, and you can see it is giving an error first time, and it's only first time, else it is actually working as it is supposed to work. You can see the pressure and the temperature printed out, and if you had the display connected, you would see the same. It's not a beautiful printout I have here on my display because there's quite many characters in the string here. But anyway, it works, and this is just for testing. I have not getting that commented out because it's printing out the when we send the command. Where is the command? It is no. It is this. I think it is this. This thing we saw here in the main here. It is this heap allocation check here. A lot of addresses, I suppose. It could be commented out. It doesn't matter. But this one is printed out in the OLED task, and the other one is printed out in the sensor task. So don't call the OLED I2C init. Call the one belonging to the sensor in the app main, and then it is actually doing, as you can see, working fine.